Hello students, how are you all? Hope you are all fine and safe at your homes. So let's continue with the numerical revision. We have revised these of the formulas in the previous video 1, 2, 3 and 4. Okay, now today we will be covering other type of the numericals based on these formulas. First type is the formula R is equals to rho L upon A. R is the resistance, as we all know. Rho is the resistivity of the material, and L is the length of the material, that is conductor, and A is the area of cross section. Right. Next is based on the heat. We are having three formulas based on heat. H equals to VIT, H equals to I square RT, that is Joule's law of heating also, and H equals to V square over R multiplied by T. Next is the formula for power. Power is having these three formulas that are being used over here, and power equals to VI, power equals to I square R, and power equals to V square upon R. Right. Now next one is E is equals to P multiplied by T. E is the energy consumption, that is electrical energy consumption in our case. P is the power of the device, and T is the time for which the device is being used. So first set of questions that we will take is based on these formulas. R is equals to rho L upon A. This is very important formula, and I have given you the worksheet number 4 based on all these types of formulas. So from that worksheet only I will take the questions to understand. Okay, so that worksheet was from this book. The question number 1, question number 2 and question number 3 I will be doing in front of you, that are based on this formula. Okay, we have actually 2 to 3 types of questions based on this formula. So first type of question is question number 1. Let's look at that. I am reading the question. Calculate the resistance of metal wire of length 4 meter and area of cross section 1.55 multiplied by 10 raised to power minus 6 meter square if the resistivity of metal be 2.8 multiplied by 10 raised to power minus 8 ohm meter. That means what are the things given? We are given the length, we are given the area of cross section, and we are given the resistivity. Okay, we have to find out the resistance. Fine. So first type of question based on this formula, R is equals to rho L upon A. First type of question is, in this question we are given resistivity, we are given length, and we are given the area of cross section, and we have to find resistance. This is the simplest form or type of the question. Okay, so this is type 1. According to this formula I am discussing. In this question, what is the length given? L is equals to 4 meter. Area of cross section I can write on capital A as it is in the formula, that is 1.55 multiplied by 10 raised to power minus 6 meter square. Resistivity rho is 2.8 multiplied by 10 raised to power minus 8 ohm meter. Remember, the units of every physical quantity is very important, right? So all these are in SI units. So we will directly put the formula. R is equals to rho L upon A. Okay, to find out resistance to be found. Fine. Resistivity is 2.8 10 raised to power minus 8 multiplied by length is 4 meter, area is 1.55 multiplied by 10 raised to power minus 6. Right. So after solving this, what we are getting, first of all, it is important to know that we have to solve the powers of 10 separately and other part separately. 10 raised to power minus 6, 6 zeros, 10 raised to power minus 8. 6 zeros will be cancelled, so the power remain is 10 raised to power minus 2. This is how we have to solve. And other things we can multiply. 2.8 multiplied by 4 divided by 1.5, we should have a value 7.2. I have calculated it and then I am writing it down. Okay, now this is resistance and it should be in ohm. We can write down the answer by removing this 10 raised to power also. In this case 10 to the power minus 2, so decimal will come 2 times over here, so 0.072 we can write. This much is the value of resistance in this case. Now let's consider question number 2, which is of second type based on this formula. Second type based on this formula. I am reading question number 2 from your worksheet. Okay, worksheet number 4, right? Question number 2 says a 10 ohm thick wire is drawn into a thin wire so that its length becomes 3 times. Calculates its new resistance. So what is given? 10 ohm resistance is given of a thick wire and it is drawn into thin wire. That means it is stretched and it is made thin. Okay, and its length becomes 3 times it is given. So we have to find the new resistance. Nothing else is given. So for this question we have to consider the resistance, that is given 10 ohm. Okay, and the length of the wire is given, its value is not given, so length is, you can say, L. Consider it L. And area of cross section, consider it A. And resistivity, consider it rho, right? Because we are not given the values. Now the question is saying that the wire is thick and it is drawn into thin wire. Suppose this is a thick wire. I will draw over here. Suppose this is a thick wire like this and it is stretched and drawn into thin wire which is having 3 times the length of this wire. Okay, it is 3 times. So this length is L. So resistivity rho, resistance R, and area of cross section A. So when the length becomes 3 times, it becomes 3L. So resistance will also change because it depends upon the length. According to this formula, resistance is directly proportional to length. Okay, so resistance will change. So I will consider resistance R dash. Let's say resistance R dash that we have to find out. Okay, that we have to calculate. So its length becomes 3L. We will write down length in this case is 3 times of this case. And what happens to the area of cross section? Area of cross section becomes 1/3 because the length is stretched to 3 times. So area of cross section becomes 1/3. Okay, it will become thin. So it will be 1/3 of its area. Okay, now resistivity, what happens to resistivity? It will not change because the wire is not changing. It is only stretching the wire. It is not changing the material. Okay, so by stretching we are not changing the material, so resistivity will remain same. Okay, so resistivity will remain rho, that is it remains same. So length is changing, area of cross section is changing over here, then resistance will also change. So let's see how much is the new value of resistance in this case. Now R dash, we can write down R dash is equals to rho, resistivity remains same, L is 3L, and area of cross section is A by 3, you can say. Okay, now just to simplify it, it is 3L upon 1 multiplied by reciprocate 3 upon A. Okay, so L, A and rho, all these are variables, so I will keep these constant values 3 multiplied by 3, that is 9, outside the bracket, and inside the bracket I will have the variable values, that is this. Okay, so R dash equals to 9 times of this. So what is this? this is nothing but the older resistance. In this case, what was resistance? R is equals to rho L upon A. All these values are like this. Okay. So put rho L upon A as R. So we can put over here R dash is equals to 9 times of R. Okay, because it is 9 times of R. And what is the value of R? R is 10 ohms. So it will be 90 ohm. So R dash is 90 ohm. Right. This is how we will do type 2 question. Now, third type of question based on this formula can be like this. Question number 3. Let's read the question number 3, in which our diameter is given. Calculate the resistivity of material of wire 1 meter long, 0.4 mm in diameters, and having a resistance of 2 ohm. Okay, we have to calculate resistivity in this case, not resistance. Resistance is given 2 ohm. So let's write down what are the things given in this question. First of all, the things given is length 1 meter, diameter that is 0.4 millimeter, or it can be written as 0.4 multiplied by 10 raised to power minus 3 meters, because it is milli, so 10 raised to power minus 3 meters. Because diameter is given, I can write down the radius value. It is just half of that, divided by 2, as we all know it. Okay, so it will be 0.2 multiplied by 10 raised to power minus 3 meters is radius. Now, resistance is also given, that is 2 ohm. Why I am finding radius over here? Because in the formula I need the area, and area is always a circle for a wire. Okay, so area of a circle is pi r square. I need radius, right? So first of all, we will find out area, that is pi r square. 3.14 multiplied by r is 0.2 multiplied by 10 raised to power minus 3 whole square. Remember to make it square. Okay, so to solve this, the same method we will remember, that 10 raised to power minus 3 multiplied by 2, that is power of 10 has to be solved first and write down separately. 10 raised to power minus 3 ka square, that means 3 2s are 6, that 10 raised to power minus 6 it is, and make a square of 0.2 and then multiply with 3.14. It is coming out to be 0.1256. Okay, so because it is area, so it will be in meter square. I can write down it in the standard form also. Standard form is decimal should be after the first digit. Okay, so it is 1.256 multiplied by 10 raised to power, because it is coming to right side, it will be minus 7 meter square. This is area. Okay, now we have to find out the resistivity. So the same formula, rho L upon A. What is rho according to this formula? Rho is equals to R multiplied by A, RA divided by L. Okay, so what is R? It is 2 multiplied by area 1.256 10 to the power minus 7. Sorry. Yes, okay. R multiplied by A we have to write. L is 1. Okay, so in denominator we are getting 1, so we just need to multiply this one only. So it is 2.512 multiplied by 10 raised to power minus 7. And what is the unit of resistivity? It is ohm meter. We have to write down that also. So in this case, little bit different. In this type 3 question, the difference was the diameter is given and radius we have to find out, and then we have to find out the area, and then we have to apply the formula to find out resistivity. Okay, Now the next type of formula is the combination of resistors. That means we are having Rs equals to R1 plus R2 series combination, and we are having parallel combination formula, that is 1 by R1 plus 1 by R2 is equals to 1 by Rp. Okay, this is for series, this is for parallel combination, right? Now in this case also we are having many types of question for this formula. First and simple type of question that we can see is the circuit question. That means when we are having a circuit given. So from the worksheet number 4 itself I will take the questions to make you understand. Okay, so worksheet number 4 is having question number 6 like this. The circuit is given. Okay, so the same circuit I will draw, and some parts are there for the question what is asked. Let us see. Okay, now I will draw the circuit. First of all, the same circuit. This is question number 6 of your worksheet number 4 based on series and parallel combination. This is the circuit given. So in this circuit we can see both series combination and parallel combination are there for the resistances. Okay, these are the parallel combination, and this one is the series along with this complete parallel combination. Okay, now in this case, first of all we have to see what we have to find out. Okay, in this question, in the diagram given here, the potential difference across AB is 28 volt across A and B. If it is 28 volt, that means the battery is providing 28 volt, we can say like this. So we can draw a battery just to understand that 28 volt is provided across AB. So for the total circuit is having this much of potential difference. So in part A, what is asked? In part A, the equivalent resistance of the network CB is asked. Of network CB. CB is this and this. That means only the parallel combination they are asking. Equivalent resistance in the parallel combination. So equivalent resistance in the parallel combination can be found using parallel formula 1 by R1 plus 1 by R2. That is 1 upon 6 plus 1 upon 3. Okay, so it will be equal to 6, 1 plus 2, that is 3 by 6, that is 2. So Rp will be equals to 2 ohm in this case. Parallel combination is having across CB 2 ohm. Okay, now this 2 ohm and this 5 ohm will be in series. So if I want to find out the total equivalent resistance for the circuit, total equivalent resistance for the circuit, for complete circuit is R equivalent is 5 plus Rp. This plus Rp. Okay, so 5 plus 2, that is equals to 7 ohm. So R equivalent is 7 ohm. This is not being asked in the question. I am just telling you how to calculate the total resistance in this case. Okay, now in part B of this question, the current flowing through AC is asked. Current flowing through AC. AC के through जो current flow हो रहा है, that is the total current according to the circuit. We can see total current which is flowing from positive terminal of the battery and through AC also. So that means we need to find out the total current. Okay, just to find out total current, we can use Ohm's law. V is equals to I R and I is equals to V upon R. Okay, what is V? To find out total current, we need total V and we need total R. to find out total current. We need total V and we need total R. What is total V? That is provided by the battery, that is 28 volt. 28 volt. Okay, and what is total R? Total R we have found in part 1 itself. I have found because I know it will be used in part B. Okay, otherwise you have to find out first this one in part B. So total R is 7 ohm. So it will be like this. So the answer will be 4. So I is actually 4 ampere. Total current flowing through AC is 4 ampere. Okay. Now in part C of the question, the potential difference across AC is to be found. Across AC, the potential difference. Okay, because in series combination we know the potential difference is different. Series combination is this and this. AC and CB are in series combination. So across AC the potential difference is different from potential difference across CB. Okay, so this potential difference I want to find out. Here potential difference in part C, V can be found using I and R, and potential difference across AC hai, so we can write down as potential difference across AC. So what will be that? I is through AC. What is I? Through AC, what is I? That is total current we have found in the previous part, like in this part 4 ampere. Okay, so I will be here 4 ampere multiplied by R. What is R in AC? That is 5 ohm. Okay, so 4 multiplied by 5, that is 20 volt. So potential difference across AC will be 20 volt. Okay, we need to take care only this much, that whatever potential difference we are calculating, the current will be through that branch and the resistance will be that one only. Okay, if we want to find out the total potential difference or total current, we need total V and total R. Okay, this much we need to understand and we need to keep in our mind. Let's see what is part D. The current flowing through 3 ohm resistor. Current flowing through 3 ohm resistor. Where is 3 ohm resistor? This one. What is the current flowing through 3 ohm resistor? Okay, this must be different because there are 2 branches after this. After point C, current is divided into 2, I1 and I2. What was total current? That was 4 ampere, and it is divided into 2 parts. So how much is the current flowing through this? We need I. Okay, we can say it is I1 or it is I2. So we need I1 over here. I1 can be V upon R. And what is V? V should be across this 3 ohm resistor. That V we have to find out. And वो हमें पता नहीं है अभी. Okay, what is R? R is 3 ohm resistance is 3 ohm, so R is 3 ohm only. Okay, so in this branch I want the current. Fine. Now first of all, to apply this formula I need to find out this V. V across CB we need to find out. So VCB is equals to IR. Across CB is having total current as I1 and I2, which is equal to 4 ampere, because across CB, across 6 ohm and across 3 ohm, the potential difference will remain same as these are in parallel combination. So what is the current across CB? It is the current same as across AC because it is in series with AC. Okay, now current is total current, that is 4 multiplied by resistance. Resistance is which resistance? That is across CB. Across CB, what is the resistance that we have found in part 1? Parallel combination. Resistance was 2 only. Okay, so that is this one. So it is 8 volt. VCB is 8 volt. So it is 8 over here. And what is R? R was 3. So it is this. So it will be 8 by 3. That means it is 2.6 ampere. So I1 is actually 2.6 ampere. Right? Now there is another type of question in this formula, that is how many resistances can be connected. This is how this type of question is given in your NCERT also. How many type of resistances can be connected in how many ways. Okay, so there is one question in your worksheet. This is question number 7th. Okay, given 30 ohm resistances, how would you connect them to give a total of 90 ohm, 10 ohm, 20 ohm and 45 ohm resistances? So how to connect? We have to find out either in series or in parallel or make a combination of all these like that. Okay, so let's do this type of question based on the formula. This is question number 7 based on series parallel. So we have 3 resistances, this and this, 30 ohm, 30 ohm and 30 ohm. Okay, first case is giving me 90 ohm. So 30 plus 30 plus 30 it should be. So if all are connected in series, we can say it is giving us 90. That means RS equals to 30 plus 30 plus 30. Very simple. 90 ohm. Okay, in the second part it is asking 10 ohm. 10 ohm is very less as compared to 30, so it may be in parallel combination. If we connect all these 3 in parallel, so it will be 1 by Rp is equals to 1 by 30 plus 1 by 30 plus 1 by 30. It will be having LCM as 30, so 1 plus 1 plus 1, that is 3, so it will be 10. That means Rp is equals to 10 ohm, like this. Okay, part 3 is little bit different. Part 3 is saying we need 20 ohm resistance. If we need 20 ohm resistance, so 2 must be connected in some different manner and the third one must be in different manner. So in this case, if we connect these 2 in series like 30 plus 30, it will be 60, and across these 2 there is one resistance of 30, the last one, third, like this. If we connect it like this, then we will get 20 ohm. Okay, how? 30 plus 30 is 60, so and this one 60 and 30 will be in parallel, so 1 by Rp is equals to 1 by 30 plus 1 by 60. Okay, so that will be 60 and it will be 3. Okay, so that will be 2, so this will be 20 ohm. We get 20, right, like this. And in the fourth part we are getting 45. How we will get 45? So in another manner we can connect 2 in parallel and then 1 in series. So 30 and 30 in parallel, that means 1 by 30 plus 1 by 30. How much we will get? It will be 2 by 30, that will be giving Rp is equals to 15. So 15 and 30. Okay, they will be in series. So Rs equals to 30 plus this 15 ohm. It will give me 45 ohm, which is required in the question. Okay. Now another type of the question based on series and parallel can be like this, which is given. This is a different question. Let's understand this also. Question number 5 in your worksheet. A wire of resistance 10 ohm is bent to form a complete circle. Find its resistance between diametrically opposite points. Okay, so what is given in the question? We are having a wire which is having, suppose this is a wire. This is question number 5 in your worksheet. Suppose this is a wire and it is having resistance 10 ohm. Okay, it must be having particular length. a particular wire, it is bent to form a complete circle. So wire is bent to form a complete circle. Okay, that means length remains same. Okay, its area of cross section remains same, no change in the total resistance, that is 10 ohm only. So what is to be found in this case? Find the resistance between diametrically opposite points. Diametrically means diameter is this one, suppose, and opposite points is this one. Diametrically opposite points, suppose these are points A and B. In diametrically opposite points we have to find out the resistance, that means equivalent resistance find out karna hai. Okay, for case of diametrically opposite points, the half of the circumference is above and half of the circumference of the circle is below. That means length of this part is L by 2 now, and this part is L by 2. So this resistance I want to find out equivalent resistance, and this resistance also I want. So if length is changing only, the resistance is changing. Okay, any other thing is changing, resistivity is not changing, area of cross section not changing, only the length is becoming half. So because of this formula, R equals to rho L upon A, L is directly proportional to resistance. These two are same, so L is half, so resistance will also become half. So what will be the resistance of one part? First part, it will be 5 ohm, half, and what will be the below part? That is also 5 ohm. This is also 5 ohm, this is also 5 ohm. These two are connected in parallel. Okay, across AB we have to find out equivalent resistance. So for parallel we will use the formula like this: 1 upon 5 plus 1 upon 5. These are the two resistances, so it will be 5 and this will be 2 over here. Then RP will be 5 upon 2, that means 2.5 ohm. Okay, this is how we have to find this type of question. These in this question, the parallel combination concept and the concept of the length and resistance relation is given. So we need to go for both the type of formula to complete this question. So in the next video we will be considering heat and power formulas, right? Hope you understood how to do these kind of numericals. Thank you.